Alrighty, this video is going to be on solving log and exponential equations, just because I don't know who's going to be out on ACT day, and I would rather have this video so that everyone can watch it, so that they are prepared by next Tuesday, aka test day. I'm only going to do 6 problems, and these 6 problems are going to be very different from each other, but on Thursday, whenever we have the long day, we're going to do a lot to practice with a little bingo game. So hopefully then we are confident with these 6 problems. Because honestly, the bingo is just a variation of these 6 problems. So let's say that I have log base 7 of x plus 13 and log base 7 of 3 minus x. And honestly, as a reminder, this isn't new. We've done this in Math 3 Honors. And what you'll notice about number 1 is that since they're the same bases, we could just drop them and then solve for the argument. So x plus 13 is equal to 3 minus x. I'm going to add x to both sides. 2x plus 13 is equal to 3. Subtract 13. 2x is equal to negative 10. And then x, if I divide by 2, is negative 5. Are we done? We are not. Remember, whenever we have something that is in the argument and we're solving for the argument, we have to make sure that our final answer is not extraneous. So if I were to plug in negative 5 here, I'm going to get positive 8. And then if I were to plug in negative 5 here, I'm going to get 3 minus negative 5, or 3 plus 5, or 8. Since both of my arguments are positive, aka they're not negative, we know that negative 5 works and it is not extraneous. Oh, Buddha. All right, number 2. Let's say that we have 2 ln x plus 3 is equal to 1/4 of ln 16 plus ln of x plus 7. Before we do any combining on the right side, aka ln 16 and ln of x plus 7, you want to make sure that we don't have anything up front by the ln's. In this case, we do have this 1/4. And of course, on the left side, we do have this 2. And if I'm going to use the power rule, I'm going to get ln x plus 3 squared. And then ln 16 to the 1/4. On the right side, I can simplify the 16 to the 1/4 by saying the 4th root of 16. So this is saying what times what times what times what will give us 16. That answer is 2. So now I have ln of 2 plus ln of x plus 7. Once we get to that part, what we are going to do is now use the product rule and multiply ln 2 and ln of x plus 7 to get 2x plus 14 on the right side. And then we have x plus 3 squared on the left. Since I have ln on the left and ln on the right, and since they're the same bases, I can drop them. So now I'm solving for my argument. X plus 3 squared is equal to 2x plus 14. Go ahead and simplify the left side. X squared plus 6x is equal to 9. Subtract 2x and subtract 14, so that the right side is 0. Now you have x squared plus 4x minus 5 is equal to 0. If I were to factor this, I'm going to get positive 5 and negative 1. And if I set each factor equal to 0, I'm going to get negative 5 as an answer and 1 as an answer. My final solution, of course, is not necessarily -5 and +1, because now I gotta play the game of plugging and chugging to make sure that they are not extraneous. So to do that, I'm gonna look at my original equation, like my original equation. So this right here. Well, if I were to plug in -5 here on the left side, I'm going to get ln of -5 plus 3 or -2. We know that we can't have a negative argument inside here. So we know that -5 is going to be extraneous. So we're going to cry for 2 seconds and mourn that -5 is extraneous. Then we're going to check 1. 1 plus 3 is 4. 1 plus 7 is 8. Since this is positive and this is positive, I know that 1 is my only solution for number 2. Now, in these two examples, we had log is equal to a log, so something was equal to something. But in example 3, we're going to see that I don't have a log is equal to a log. What I have now is a log to a number. I'm going to isolate the log. So I'm going to add 9 to both sides. That's going to give me 7. Now, do not, I repeat, do not drop your base and just say 5x plus 23 is equal to 7. Do not do that. No. Instead, log roll it. So now you have 2 to the 7 is equal to 5x plus 23. Let's say that you weren't given a calculator and you needed to figure out what 2 to the 7th is. Hopefully you know what that is because it is 128. If you don't, then brush up on your powers of 2s. 128 is equal to 5x plus 23. I'm going to subtract 23 on both sides. So that's going to give me 105 is equal to 5x. Divide by 5. So that means that x is equal to 21. Or so I think. I don't know. Well, if I were to plug in 21 here, I'm going to get 5 times a really big number. Well, 5 times 21 is 105. Plus 23 is 128. Since 128 is inside my argument, aka it's not negative, then we know that 21 works as a solution. That's all I'm doing for logarithms. Like I said, we'll do more practice on Thursday, and on Thursday, you'll see that these problems are essentially the same thing, except with the different numbers. Our next part of the lesson is going to be on exponential functions. And with exponential functions, once again, most of these are not new. For number 4, you're going to need to make sure that we have the same base. Just like how here on numbers 1 and 2, we made sure that we had the same bases. Well, for number 4, I have a left side of 1/27th, and on the right side, I have a base of 9. I need to think, 1/27th and 9 has a common base of what? And if you guess 3, congratulations, you're right. So you have 1 over 27. 27 is the same thing as 3 cubed. And then 9 is the same thing as 3 squared. We're getting close, but my left side is still not a base of 3. We have 1 over 3 to the 3rd power. So what I'm going to do is move that 3 to the 3rd power up by taking the reciprocal. Then I am going to use the power property. And I'm going to multiply -3 and 2x minus 6 to get -6x plus 18. And I'm also going to get, let's see, 2x minus 2. You'll notice that my bases are now the same, so I can drop them and just solve for the exponent. I'm going to subtract 2x on both sides, so that's going to give me negative 8x plus 18 is equal to negative 2. I'm going to subtract 18, that's going to give me negative 20. Then I'm going to divide by negative 8. So x is equal to 20 over 8, which is 10 over 4, which is 5 over 2. So your final answer is 5/2. Now, good thing about these types of problems is that we don't really need to check for arguments being negative and whatnot, because the domain of an exponential function is always all real numbers. So for any x value you get, it is what it is. So there's no need to check for extraneous solutions. Number 5, we have 5x minus 1 is equal to 90. Notice how we don't have an exponential is equal to exponential. We don't have same bases. We have 5 and 90, and those aren't really common. So what we're going to do is turn 5x minus 1 and 90 into a logarithm. So now I have log base 5 of 90 is equal to x minus 1. I am going to add 1 to both sides. And my final answer is log base 5 of 90 plus 1 is equal to x. You might be expected to put this into the calculator and give me the decimal equivalent on the test, which is 3.7959. Now, if you somehow get the bootleg version, aka the 83, where you can't type this in, remember last week I talked about the change of base formula. You're going to need it. If you can't type the pretty version of log base 5 of 90, you're going to have to type log of 90 over log of 5 plus 1. All right. Number 6 is a really fun one. Like a really, really, really fun one. Notice how I have two exponentials for number 6, and they're not the same base. And we can't really make 3 and 8 to be the same thing, unfortunately. So what we're going to do, just like number 5, is we are going to turn one of them into a logarithm and then see what happens next. As a warning, be prepared for number 6 to be long, so pay attention carefully on what my steps are going to be. The first thing that I'm going to do is make sure that I can't really simplify anything, so that we go on to step number 2, which is put the left side or the right side into a logarithm. I'm going to put the left side as a log, so now I'm going to have log base 3 of 8 to the power of x minus 5 is equal to 4x plus 1. This is valid because, remember, if I were to log roll this, I'm going to get that lovely thing right here. Once I get to this, I have a variable on the right, my 4x plus 1, and then I have x minus 5 in my exponent. And I don't want that. However, remember, one of the log properties is that we can bring this exponent up front. So now I have x minus 5 log base 3 of 8 is equal to 4x plus 1. So that is a valid property, me just moving the x minus 5 to the front. Now I have x minus 5 times log base 3 of 8. Can't really simplify log base 3 of 8, so I'm just going to leave it like that. And then I have 4x plus 1. Since my x minus 5 is being multiplied by the log base 3 of 8, I am going to use the distributor property to isolate the x. So now I have x times log base 3 of 8 minus 5 log base 3 of 8 is equal to 4x plus 1. I have my x kind of isolated so that I can turn my two x's into 1x by subtracting 4x to the left side and then adding the 5 log base 3 of 8 to the right side. So right now, my next step is to rearrange my terms so that I have my variables on the left side and then my constants on the right side. At this point, I want to solve for x, right? So I want to make sure that I have 1x. Right now I have 2 x's, so in order to get 1x, I am going to factor out an x. So now, if I factor out an x, I'm left with x, parentheses log base 3 of 8 minus 4. And then my right side is still the same thing. Once I get to this point right here, I'm finally free. Your x is free because now we're just going to divide by log base 3 of 8 minus 4 on both sides. To isolate x. So your final answer for number 6 is 5 log base 3 of 8 plus 1 over log base 3 of 8 minus 4. Now, unfortunately, if you are one of those people that got stuck with the 84, then you're going to need to change a basis. And what I would do is once you change a basis, store this value into the calculator so that you could just say 5 times whatever variable you sorted as plus 1 over whatever variable you sorted as minus 4. Now, if you have the 84, then you could just easily type this into the calculator and call it a day. Obviously, this might be a type of question that will be on the FRQ, that would be calculator inactive, where you need to solve it by hand and leave it like this. Unless I tell you to explicitly put it in the common log, then you would need to put log base 8 over log base 3. So it's a lot of fun, honestly. Really, really fun. All right, that being said, I would work on the delta math for logarithms and exponential equations and get that done because honestly, at this point, we're almost done with the units. The only new thing left would be your applications. So your doubling life, your half-life, compound interest, and all of that good stuff. That will be Friday's lesson. So tomorrow, Wednesday, and then Thursday, my long day, we'll work on more of this.